All right, so we're going to go over this triangle congruent proofs foldable, but I'm going to tell you how to fold it first. Now, I wouldn't fold it and keep it together as you do it, but you can go ahead and cut it out. I just wouldn't like fold it up together. So what you're going to do is you're going to cut along this line. Okay, so you're going to have a sheet that looks like this. This is on top, and the triangle congruent proofs is over here. You're going to cut along this line to where you have this top part and the bottom part. Okay, then you're going to fold on both of these right here. So you're going to fold right here in the middle. Okay, and you're going to overlap the two sheets of paper. The top one goes first. This is going to be the cover. And the bottom one, you're going to fold it to where this is like the cover of the book. So it's going to be a little booklet where this part right here is the cover. If you need help, let me know. I can help you. All right, so let's look at these proofs now. All right, now it's very important that you mark your diagram up. You're going to see me using my highlighter tool a lot and still using markings. Please do that. It will help you. And the more we do of these, the easier they'll become. You're going to start seeing a lot more patterns. All right, so we're given that pH and NE are, remember, this is parallel. So I'm going to use the parallel marking. So pH and NE are parallel. Okay, then we're also given that pH is congruent to EN. So that is given. So pH, I'm going to go ahead and highlight this, pH is congruent to NE. Okay, now it tells me that angle P is congruent to angle E. Now, how do I know that angle P is congruent to angle E? Okay, well, I know these two in purple are parallel, and then I know PO is this transversal that goes like this. Isn't this angle and this angle alternate interior angles? And alternate interior angles are congruent when the lines are parallel? Well, it tells us that the lines are parallel, guys. So I can write this as by the alternate interior angle theorem. Okay, and I know they're congruent, so I'm going to say whoop and whoop, just like that. Okay. Now it's telling me that angle POH and angle EON are vertical angles. Well, guys, we know that's true just by the definition of vertical angles, right? We know what vertical angles look like. When two lines are crossed, they're opposites. Well, that's this one and this one. And then we know that vertical angles are always congruent. So now that we know they're vertical, we can write that they're congruent by the vertical angle congruence theorem. Now, if I look at this diagram, I have two angles and a side, and so I can say that these triangles are congruent by the angle side theorem. And the reason it's angle side and not angle side angle is because the known side is not between the two angles. All right, let's look at proof number 2 here. All right, so we're given that EC is congruent, or AC is congruent to EC. So this here is given, and I'm going to mark it AC and EC. And then we're also given that AB is congruent to ED, which is right there. So that is also given. And then we're also given that C is the midpoint of BD. So C is the midpoint of BD. Now your brain, we've done this for 2 days now, your brain should automatically go, if we know it's the midpoint of something, that means we have two congruent pieces. Okay, now be very careful in the way we order these because we're talking about congruent triangles. So if we say that BC is congruent, well, BC is the last two letters, B comes first, C comes second, we have to say DC, not CD. Okay, so this is just by definition of midpoint, and I'm going to abbreviate that. Okay, and once again, the reason BC is corresponding parts, BC and DC, it's because BC goes in that order, DC has to go in that order too. And then triangle ABC is congruent to triangle EDC. Well, if we look here, we have all three sides, so that would be the side congruency theorem. All right, so let's look at proof number 3 in this little booklet. All right, so we're given that XY bisects angle WYZ, so that is given. And I'm also given that WXY is congruent to ZXY. So let me go ahead and mark that. So WXY, so this angle and this angle are congruent. Okay, now it tells me WYX is congruent to ZYX. So how do we know that this angle and this angle are congruent? Okay, well here's your hint. Guys, that's just the definition of bisect. Remember we did that on day 1. If something bisects an angle, it cuts it into 2 equal parts, 2 equal smaller congruent angles. Okay, now when I look at this figure, I should put an X on the side because I know they share this side. This is like a freebie, guys. This is number 1 on our hints. So I can say that YX is congruent to YX. That's just the reflexive property. And now I can say these triangles are congruent. Why? Well, angle, side, angle. I have 2 angles and a side, and the side I know is between the 2 angles that I know. All right, let's look at proof number 4. Okay, so it says angle B and angle D are right angles. Well, that's right here in the given. Okay, and then it also tells me AC is congruent to EC. That is given. I'm going to mark it. AC and EC. And then I'm also given that C is the midpoint of BD, so this is given as well. So C is the midpoint of BD. So you have to ask yourself, what does it mean to be the midpoint? What does a midpoint do? Well, guys, a midpoint cuts this into 2 smaller pieces. So that means BC has to be congruent to DC, and once again, it has to go in that order. BC is here, DC is here, so it can't be BC is congruent to CD. You'd be flipping it. So that would be by definition of midpoint. Okay, and now we do know, and I didn't mark it and I should, that this and this are right angles. Well, if these are right angles, that means this is a hypotenuse, and that means this is a hypotenuse, and this is a leg, and this is a leg. So remember, I can use that forgotten theorem, the hypotenuse leg congruency theorem, and that's all I need to show these triangles are congruent. All right, I want you to try to do this one on your own. It does look a little bit longer, but it's not harder by any means. Go slow, do the best you can, and then we will go over it. All right, so this is what you should have gotten. So the first 2, A is the midpoint of TN and A is the midpoint of HK, that is given. So you need to ask yourself, what does that mean? Okay, well, if something is the midpoint, that means it cuts it into 2 congruent pieces. Okay, so I've listed that in 2 congruent pieces. TA and NA are congruent, HA and KA are congruent, and that's just by definition of midpoint. Okay, then we're going to go down and say, well, angle TAH and angle NAK are vertical angles. Well, guys, if we know the definition of vertical angles, remember vertical angles, when 2 lines are crossed, they're opposite of each other. If we know that, then we can look at this diagram and just pull out vertical angles very easily. So I've gone ahead and marked that in purple. And now if I look at this diagram, we can show that these 2 triangles are congruent by the side angle side theorem. And the angle is between the 2 sides, so we should be good to go. All right, there's one more in this foldable. I want you to go ahead and try to go ahead and do this one on your own again, and then we will go over it together. All right, so let's go over this. So RN is perpendicular to AG. Remember, this is the symbol for perpendicular. That's given. And then A is the midpoint of RN, so A is the midpoint of this entire yellow thing. All right, so go back to the first thing. What does it mean to be perpendicular? Okay, well, perpendicular means two lines that cross to form right angles. Okay, so I know that these two angles are right angles. Okay, so I went ahead and marked the squares on them. And then way back in chapter 1, we learned that all right angles are congruent, and that's the right angle congruence theorem. You probably forgotten that one, that's okay. All right, now, how did we know that RA and NA are congruent? Well, it goes back up to the fact that A is the midpoint of RN. So if A is the midpoint of RN, it cuts it into two congruent pieces, which is RA and NI. So definition of midpoint. And then you should have noticed first thing when you looked at this, that they shared this side here with an X. Sometimes I just mark the X as soon as I see it. That means that it's congruent to itself, and we use the reflexive property to say that. And then once we have all those, we can say the triangles are congruent by the side angle side theorem. And do note that the angle we know, the right angles here, is between the two sides that we know. So side angle side is good.